Hello, everyone, and thank you for joining me on the CR Stelck Petroleum Chair Seminar Series. And this is the second seminar in that series. And today we're going to go on a virtual field trip to the Bay of Fundy. It's one of my favorite places to visit in the whole world. You see tidal things and sedimentological features of the scope and scale that you just normally don't see anywhere else on the planet. That's owing primarily to the fact that it's macrotidal, or some people would even call it a megatidal setting. And the tides exceed routinely in the Bay of Fundy 10 meters, which is astounding. The CR Stelck Petroleum Chair really recognizes and celebrates the career of Charlie Stelck. And Charlie Stelck was a professor at the University of Alberta for a very long time, many decades, spanning from the 30s and still teaching into the 80s. And I did my PhD in the 90s, and Charlie Stelck was on my supervisorial committee. This is him visiting us just a few years ago, a little while before he passed away. And Charlie was, I think, about 89 at the time, although he could have been 90, I can't quite recall. And here's Professor Pemberton, former holder of the CR Stelck Petroleum Chair, who passed away about 2 years ago now and is dearly missed. And then the rest of my research group at the time: Dave Herbers, Michael Ryan King, Shelby Saunders, and Lena Shebekina. There's Nabil and myself, Murray. The first two CR Stelck Petroleum Chairs were Brian Jones, and after Brian Jones, then it was S. George Pemberton. Here they both are in the late 80s at the Cayman Islands doing research in one of Brian Jones' favorite research study areas. And they're both excellent mentors of mine. Brian taught me many courses as an undergraduate student and a graduate student, and of course, George the same, and became my PhD supervisor. The Bay of Fundy, shown here in this touristic map, is, at least as far as the provinces of Nova Scotia and New Brunswick are concerned, separated into ecozones. There's the highest tides ecozone, which are bordered by this orange box. And first, in fact, the highest tides are associated right with this coast right here, near Noel, near Birdcoat Head, a wonderful provincial park, well worth visiting. It's just astounding to walk around there. And the tides here have reached as high as 14.6 meters, I believe. I'm going from memory. I might be a little off, but very extraordinarily high tides. And this field trip is going to focus on the world's highest tides ecozone. Also are the sea cliffs and fossils ecozone. That includes the fossil area of Parsborough, where the famous site of Joggins, or near the famous site of Joggins, where the amphibian fossils are preserved, and also all the beautiful sea cliffs that are associated with the Minas Basin and some parts of the Bay of Fundy itself. And then in blue here, although you can't quite see the title, this is called like the marine ecozone or something like that. I can't quite remember the name of that. Here's a Google image, and you can see the main features of the Bay of Fundy include these two reaches that are the Minas Basin, which reaches to the east, and Chignecto Bay, which reaches to the northeast. They're both quite different. The Minas Basin, because it's scouring into Carboniferous and Triassic clastic rocks, has a very proliferate sand supply, and so it's a very sand-rich sedimentary basin. Whereas up here, where you go into Cobequid, it's very muddy, and that's because the seafloor here, or the bay floor, is floored by by Pleistocene muds, and so there's a lot of clay and silt in this system here. And as a result of that, you get kind of a very different character from the northern reaches of the Bay of Fundy compared to the western reaches. Both have very high tides, and both are fascinating to visit. It's worth recognizing some of the early greats that have worked on the Bay of Fundy. Bob Dalrymple is down here, lower left. Here he is sitting on an outcrop of McMurray Formation on a field trip that I was leading. And Bob did his work, well, throughout his career at the Bay of Fundy, but also really starting in the 70s when he was doing his PhD with Gerard Middleton. And Bob was really responsible for doing so much of the foundational work of on the modern view of bars and dunes and compound dunes. And that was largely the result of his very intensive field work while he was at McMaster University and working on his PhD. A contemporary of his, who I think is equally notable and important, but not on this. Couldn't find a photograph of him, was John Knight. Of course, John Knight did his PhD at about the same time as Bob Dalrymple, and really both of their works together formed a synthesis of dunes, composite dunes, tidal bars, and whatnot that I think really were a basis for a lot of the research in estuaries that came in the 90s and early 2000s. Ron Boyd, upper right here, Australian estuary researcher, really understood the morphodynamics of estuaries, the stratigraphy of modern estuaries, and the processes and the range of processes that are variable in estuaries. Part sedimentologist, part oceanographer, Ron Boyd really contributed heavily to this body of work that became really a central theme of research throughout the 90s, which was on understanding estuary facies with models. Brian Zaitlin on the upper left here was equally foundational. He worked with Bob and Ron, and Brian was the person who really started bringing, he did his PhD in Australia with Roy. Roy was a really famous estuary researcher in Australia. And Zaitlin went down there, Brian Zaitlin, and he brought some of that back to work with Bob and ended up working with Ron Boyd as well at the Bay of Fundy. And they've essentially built what we would call the tripartite estuary classification for estuaries, something that was a bit of an abstraction, but really was an effort to understand the process distribution in estuaries and how that influenced their physiography. And I kind of feel like Brian was the linchpin in all that and bringing it together. And then lower right, Dashtgard did his PhD in the Bay of Fundy in the early 2000s, focusing more on the coarse grain systems along the northern shore of the Bay of Fundy proper. And Shaw's work ended up being a basis for the classification and identification of tide-dominated shore faces and a lot of other tidal work that came thereafter. This photograph shows Shaw when we were working together back around 2000. This photo is probably about 2005. And we were actually collecting gas samples from these deep tidal channels in the winter. And it looks kind of, wintry out there, but it was a gorgeous and fun day. How does a field trip to the Bay of Fundy actually start? Well, you have to fly to Halifax, or you can fly to Moncton. Those two places are preferable. But whichever you fly into, you're going to have a seafood meal for dinner that night. And so here's myself, Professor Zonneveld, and the Ichnology Research Group. And we're all having our lobster bibs on, and we're ready for a big lobster feast. And as I recall, it was a grand time and a super evening. And then over here, you can see that's later in the evening back at our Airbnb, of course, drinking a bit of whiskey, playing cards, and, well, cribbage, of course, and just all in all having a good time. You got to behave, though, because you got to get up early the next morning to catch the tide. And the first field day, the second field trip day, takes us to Selma, Nova Scotia. So this is near where the highest tides in the world are recorded. And this is where Selma is, down here, a set of houses. It's just a hamlet, you might call it. We drive up here, we park right here. We got permission from the landowners up here, and then we accessed along this creek, and then it becomes a tidal drainage creek here. And ultimately, then you can see the coarse clastics at the shoreline, kind of a muddy inner tidal flat, and a more rock, I would say rock stripped of sediment, lower tidal zone, and then ultimately it gives way to a tidal channel in a large sand complex that is characterized by simple and compound dunes of variable orientations, as you can see here. But I can assure you, when you go out there, they're all ebb oriented, meaning they're all oriented in the direction of the drainage to the low tide, and they'll be reworked or reformed into flood oriented dunes when the tide comes in again. Stepping back a bit, Truro, Nova Scotia is over here. Halifax, if it were on the map, would be over here somewhere. And then Selma is here. And so we're just at this kind of knob about halfway up the Minas Basin. And what we want to do is kind of traverse around here and cut across to here, which is what we'll do. Here's Professor Zonneval, JP, and he's standing on the stripped bedrock where the tidal energy is just so strong, it just won't allow sediment to settle there. Everything's transported off. And in fact, it's so strong that you get these flutes and scours in the bedrock. And look how the mud has all of these scours, flutes, and parting lineations in it. And it's just evidence of the very high hydraulic energies that are related to the, in this case, the ebbing tide, but the flood tide. The flood tide is nearly equally energetic, and it really is a fantastic thing to see. Casting about the area, you'll see that there is a coarser grained innermost tidal flat. That's because that's sediment that's enriched by waves when the tide's high, and in some cases eroded from the outcrop that's standing in behind here. It grades rapidly into a mud flat. You can see there's lots of shorebirds on here, and that's a good indication that there's lots of critters living in the mud, and mostly worms or polychaetes, such as Nere's virens, I suppose, and also little arthropods, Chorophene volatator, small amphipods that are like wee little shrimp. And then this gives way to the tidal channel and then the composite bars that are out there. This is a flower pot. You can see the local Triassic bedrock in this case. This Triassic bedrock is the Wolfville Formation, and it's forming a flower pot vegetation on top. This is all relict. It was once part of the mainland and over time was cut off by tidal erosion. And there's a lot of flower pots around the Bay of Fundy. So a lot of people like to come there and take photos of them because they just look pretty cool. And now we're going to look at an overview of the Selma area using some drone footage that we collected while we were on this Technology Research Group field trip. All right, we're looking at drone footage. Here's the research group right in the foreground here. And you can see some of the students are engaged with looking at the Triassic outcrop here. Here's one student that's lost in thought looking at the mud flat. And here's one of the Scots down here looking at some bare rock, and you can see here the mud flat grading to the stripped rock zone to the sand bed zone and whatnot. And we're just going to have a use of the drone to have a quick look at the overall area. So the drone will take off. First off, you can see the outcrop here. There we are actually doing some of the drone work, Sheridan and Scott. And here's, you can see the cross bedding of a very kind of a lenticular geobody that's probably a fluvial body. There are fluvial units in here, including dunes, and you can also see it's kind of a red bed. It's reddish in color, and there's these greenish levels that are comparably reduced levels within the red beds, which is just a different type of iron bonding with less oxygen. Continuing to look about, you can see the extensive outcrop, the rocky innermost tidal flat, which is concentrated by waves at high tide. And we have the mud flat. You can see we cordoned off an area here that we were doing an ichthyological study on the relationship between birds' tracks and burrows. And we'll get back to that. But here you see nicely the mud flat grading to the stripped rock sand flat, grading to the sand dunes and compound dunes that make this large bar off in the distance. Looking around a little further, there we can see the flower pot on the left, and you can see the sand flat now. It's big. It's as far as sand goes, it's probably about 10, 11 meters of sand thickness, all compound dunes. It's several kilometers long, a couple kilometers across, and it's a really, really fantastic area to go visit. With the drone footage, we can actually keep looking about, but I think what we want to do is, yeah, get a little higher up here. And now you can see this is where some of the stripped rock is, all from the very high energy tides, making this roche moutonné kind of look of rock and mud behind it, and then the simple and compound dune field off in the distance. The drone work gets a little jerky sometimes. I actually didn't take the drone footage with the idea of a virtual field trip in mind, but actually it works pretty well. Just back up a bit now that we're higher up. You can see the research group's tracks, our own ichno traces, if you will. And you can see where we went out and had crossed over to the sand channel here. We'll get to that in a little bit, mind you. And again, we can see out over the bay and the dunes and the flats. And after that, we just land the drone, and that's how muddy your feet get. For now. Better late than never, I suppose. So that was our overview of the Selma tidal flat. So you can see it's really large, and there's a lot of things to go look at. So let's have a closer look at some of these. Here's Dan Baker, one of the funnier young grad students I know. Genuinely, he's a hilarious person. And then you can see there's cross bedding here. There's actually a lot of amalgamated fluvial channels in this Triassic formation. And like I said, you can see that it's red because it's oxidized. It's associated with subaerial exposure. But you also see these greenish beds, which are comparably reduced iron, but still oxidized iron, that are associated with maybe a fluctuating water table underneath a low standing wetland or something like that back in the Triassic. And on the right is something that everybody always discovers at this location, which are these round things that have these spherical or concentric appearing rings on them. And people always bring them to me and they're like, oh, this is a trace fossil. Maybe it's Rosellia or something like that. And they're always disappointed to find out these are inorganic structures. These are reduction spheres that are quite often occurring around little rootlets and material like that in the sandstone. And the reduction spheres are made almost entirely of pyrite cement that form these spherical and botryoidal masses within the sandstone. You can get a closer look at the bedrock, and where you do, you actually see that it's encrusted with a nearly marine assemblage of animals and plants. And for example, there's sponges, some type of kelp or algae, and there's bryozoans. These are bryozoans here, and there's barnacles, and there's sometimes even tube worms and stuff like that on these rocks. So the intertidal zone is a good exploration for these types of animals. Carolyn Furlon is here. That's her, a bit of there looking appalled, but she's a vegetarian and she doesn't like what's about to happen, because to become a Nephthys warrior in the research group, you need to eat a Nephthys on the tidal flat. And it's considered good form to eat a larger Nephthys than this. And I won't say that I'm disappointed in Carolyn with her choice of Nephthys. Sometimes you don't have a choice. It depends how abundant they are, where you are. But she's about to eat one to confirm her Nephthys warrior status. Although I think she was a Nephthys warrior already before this photo. Now we're going to look at some of these tidal creeks. We have drone footage that actually will take us through these tidal creeks. And these tidal creeks are great because the tide range is so extreme at the Bay of Fundy. Then, of course, what happens is you get deeper incision of these tidal creeks into the tidal flats. And already before we even take off, you can see in this tidal creek, there's this dipping bedding towards the nose of this point bar. Well, that is a laterally accreting bed form. It's a point bar. It's a tidal point bar, strictly only tidal. There's no fluvial influence on this channel at all. Now we're going to take the drone and we're going to hopefully take off. There we go. We're just going to go along this channel a little bit. Notice on the right, we have a laterally accreting bar. On the left, we have a cut bank. Ahead of this point bar, we have a new cut bank. So the laterally accreting bar, if you want to call it that, is translating into a cut bank, which you might expect. There we are, JP, myself, and Sheridan, just watching and controlling the drone. We generally there, and here you see Cobley Beach. How does this Cobley Beach get in there? Well, you know, it's sourced from the outcrop in part, but the other thing to remember is that when the storm comes into the Bay of Fundy and the tide is high, then this becomes the shoreline, and the waves crashing here winnow out the finer grain material and leave behind the Cobley Beach. There, now we can get a better view of the tidal flat. You can see the tidal channel here. Here's another point bar coming down here. You can't see it everywhere, depending on the exposure. There's another channel here. And these channels are characterized by their order of branching. First order is one channel. Second order is where it bifurcates into two. Third order is where it bifurcates again. So you get into higher order tidal channels as you go in the landward direction. And here you can see the mud flat. That's more of the innermost flat here. There's the tidal channel. The students, JP and I, actually walked across here so we could go to this compound dunes. But I was a little nervous. We were all uncertain exactly when the tide was coming in that day. So we just poked out there and we came back. We never spent a lot of time there. And certainly you really have to establish what the tidal charts are telling you for that day. And you need to be familiar enough with an area to know how well behaved the tidal times are in a certain area. We'll talk more about that at Economy. But there's a good view here where you see a lot of these are dunes. The dunes are either flood or ebb oriented in their structure, but when you see them exposed at low tide, they're almost always ebb oriented because that was the last strong current that they suffered. Still, you dig into them and you'll sometimes see bidirectionality in these dunes. When you walk out on the tidal flats, you see a lot of great things. It's muddy. That's why we wore our mud boots today and shorts. If you wear long trousers and rubber boots, you'll almost certainly get stuck, and it's a very dangerous situation if you get stuck. On the left are these little branching traces. These are surface feeding traces of an animal that's living in the sediment, probably an Nereid polychaete in this case, although there is a type of bivalve, Macoma baltica, for example, that will reach out to the sediment water interface and do something very similar. And it takes a practiced eye to tell the difference. On the right, what do you think these are, these squiggly things? 50 years ago, you might have referred to them as Runselmarken, but that would have been a little incorrect. They're not really wind adhesion ripples. Rather, these are microbially induced sedimentary structures where cyanobacteria have given the rheology of the mud a plastic rheology, and it can deform plastically such that you preserve these wrinkle marks and these dimples. and amongst these traces here. So these dimples and wrinkles are really common in rocks that have were microbially stabilized. We see them, for example, in the Ediacaran, in the Cambrian, and in the Ordovician. After the Ordovician, features like this become less and less common because the Cambrian and the Ordovician are when biomats are still really important in a dominant part of marine biomes. But as you get into younger and younger times, then the prevalence of biomats in subtidal settings becomes quite rare, although you can go on many tidal flats around the world today and see features like these microbially induced sedimentary structures. Some of these here on the right are as good a preserved or displayed as any I've seen. A good ichnologist can identify the animals that are present in the water mostly just by the type of poops that are available here. And here on the right, you can actually see these Nereid polychaete burrows, which are right here, making these vertical and horizontal locally branching shafts. And there's even a bivalve, and the bivalve was reaching up through to the sediment. That's Mycoma baltica there. So we commonly would stop on a field trip to look at some of these features on the surface. And just to show you that orthogrammetry that we collected with the drone, this is what Scott actually put together from the orthogrammetry. Each black dot is a worm burrow. And you notice the density of the worm burrows on the left. And we were just trying to get some spatial analysis of worm burrows versus bird tracks. And Scott painstakingly plotted every bird track on this image. And it's a fantastic result. And you can see the correspondence between the bird tracks and the worm burrows, right? And which of course you'd expect, but it's nice to see, I mean, under such pedantry are great scientific hypotheses formed. Back in the early 80s, Ross Eo and Mike Risk put together this facies model for these megatidal mud-dominated settings. It was one of the first ones from North America. There had been earlier work from the North Sea by several of the German crowd that were really into neoichnology and neosedimentology. But this Eo and Risk paper was a bit groundbreaking in that it was based on the Bay of Fundy and shows exactly what you see at the Selma location. Cross-bedded sandstones, which might be related to dunes in the channel or the compound dunes adjacent to it, grading into mixed sand mud, grading into bioturbated, laminated mud, but maybe so bioturbated you can't see the laminations, and then giving way to a backshore. And all in all, I find this sedimentary model to be most agreeable. And when you go to Selma, for example, this is more or less the facies model that you see. Now we're going to walk to the sand island, and you can see we're in a tidal channel here. Now remember, when the tide comes in, this is going to be another 9 meters above our head. So we're in very deep water when the tide comes in. It doesn't take that long to get up to several meters. And also the current energy there can be 2 meters per second. So like a river in flood. And you can see that from the scale of the dunes and the scoured bedrock. And of course, because the current energies are high when this is ebbing or flooding, there's large dunes in the channel. So here you can see Ryan at the crest of a dune, whereas poor Maya has went off the crest of the dune and up to her waist in water. And so it makes for a bit of a treacherous crossing. Getting across, I went to that cross and did some orthogrammetry, but it gives you the feel. We're going to have a better look at a compound dune field at Economy Beach. So I'm just going to leave this slide at that. And then just remind you, here's a paper by Dalrymple and Rhodes, where Dalrymple, this is 95 from the geomorphology and sedimentology of estuaries. And Dalrymple put together this paper that shows the different bounding surfaces and internal structures of tidally influenced dunes and how they actually develop. But I mean, it was really foundationally based on all of his Bay of Fundy work, which included work near Noel and Selma, where we were just at on the field trip. Now, day 3, we gone out for seafood dinner again. We're back on the road, and we're on this exact same part of the bay, but on the North Shore in New Brunswick, and we've gone to Economy Point. I adore Economy Point. It's such a beautiful place, and we have so much fun every time we go there. You can see here again, we got an inner sand flat, and it goes into a sandier zone where there's just a huge sand field out here. Tide's still pretty high, so we're not seeing the sand that well displayed. And on the landward side of the tidal channel we're going to cross, we're again looking at Wolfville Formation Triassic strata. And here's a very large fossil dune that's preserved in that strata. There's lots of encrusters on the rocks, including bryozoans, kelp, and barnacles. And what we're going to do now is we're going to cross the tidal channel and look at the video of the Economy dunes. So the Economy dunes are actually great. It's a 6-kilometer long complex of sand. It's about a kilometer wide, give or take. You can walk out to it, but it's extraordinarily risky in some ways because the tidal channel there fills with a bore. So if the tide beats you to that channel, you're in a spot of trouble. And you can ask a few of my colleagues about it, but we're going to go, but we'll talk about that when I show a video about that channel filling up. Okay, we're just spinning around here, but now we're looking more or less to the northwest, and the town of Economy is here. I'll just back this up a little bit, and you can see the scale of this large compound dune that we're on. Now, this channel right here is the channel that you have to cross to get out here. And if you ever go to Economy and you're tempted to cross that, you have to be very mindful because it's only ankle deep at low tide. And when the tide comes, that channel actually fills so rapidly. It fills so rapidly that if you're even 3 minutes after the tide starts, you're probably not going to make it back to safe land. So you don't have any room for error at that location. Keep looking around. You can see it's a decidedly gorgeous place. Lots of tidal channels, lots of dunes. Just to give you a feel for that. And now I want to give you an opportunity to see the scale of these dunes, and we're just going to look down. So here's me and my students in JP, and these are the dunes, and you can see there's smaller dunes on top of the bigger dunes, and you can see for scale that their spacing is, oh, I don't know, it's a few meters anyway. These Economy dunes were amongst the dunes in the data set that were analyzed by Knight and Dalrymple, Zaitlin. In fact, yeah, this photo's from a paper by Dalrymple, Knight, Zaitlin, and Middleton. That's quite an authorship team. I would like to have been on that paper, that's for sure. But you can see some of the dunes that they very carefully excavated from locations like Economy Beach, showing their different structures, where you have simple dune migration, where you have dunes with reactivation surfaces, where you have dunes with reversals in them, and so on. And so all of these really contributed to a better understanding and knowledge of tidal dune systems. Carolyn Furlong did her work at this location as well because she was working for her master's with JP and I on board clastic rocks. And here, these are all bivalves of the Zerphea Pillsbury and Petricola falatiformis. Those are the bivalves. And they're boring intensely into these rocks. And you can see that somehow they managed to excavate this sandstone over time. These are intertidal animals, so they're submerged by the high tide every day, and that's how they can live there. But it's really quite amazing how much bioerosion is going on at this location. We would walk out to the dunes if we had time and we decided it was safe. And you can see here, there's the research group in the background, and here's some of the dune crests in the foreground. And there's a very happy and excited group of students and JP, who's happy and excited as well. And I think you can see that it was a glorious day on the Bay of Fundy. Now, one thing I didn't mention is that channel that we have to cross is called the Decod. And it was named after I almost got myself, JP, Sarah, Alina, and Carolyn in trouble when we're trying to cross the death channel of death. That's what DCOD stands for. So Carolyn named it the DCOD, the death channel of death. And I just want to show you the video that we took at the death channel of that death. So at the death channel of depth, the tide is just coming in. So we're on the safe side of the channel here. But the day before this video was taken, JP, Carolyn, Sarah, and Alina and myself were caught in these currents here. And we actually got ourselves in a bit of pickle. It wasn't the only time that we were caught in this channel. I was caught once with my wife, Vivian, and Tom Saunders, quite a long time ago now, around 2002. I've been caught there with Shahin Dashtgard and a couple other students, and you can see why. I'll just now look at the time marker here, 15 seconds, and here the tidal current starting to come in, right? Okay. We're going to just fast forward this. We can still cross it now. Water's knee deep, okay? 40 seconds in. We're going to go 2 minutes in. And now you can see the channel is probably getting a little challenging to cross. And by the time we're at 3 minutes, you're basically talking about a river that's greater than waist deep. It's probably chest deep on me, and I'm not entirely sure you could make it across. And in another 2 minutes, forget about it. It's all over. Was someone trying to say something? No, that's good. Okay, and then I'll just fast forward you a bit because, you know, on field trips, it's always okay to have a little bit of fun. There's JP floating down the river. We were jumping in and out of the current, but look at those waves, those standing waves and stuff like that. It really is a lot of fun. I thought one of the students came by too. I know I'm somewhere swimming in that video too, but I don't need to waste your time. Oh, that was actually funny. At the end of that, we didn't notice how fast the tide was moving in, and we ended up being chased back off those rocks anyway. What a bunch of knuckleheads, eh? Now let's go day 4, the Petitcodiac River. Economy was fun. It was a lot like Selma. Now we're going to look at something totally different. And the Petitcodiac River is a very muddy river that's really an estuary where we look at it basically, which is south of Moncton. And here you can see a muddy, laterally accreted bar that's cut incised by intertidal drainage, okay? And this bar is accreting into the Petitcodiac River channel. I'm going to show a video of the Petitcodiac. This video just gives us a nice feel for what the area looks like. There we go. And what's that little wave coming in? Well, that's actually a tidal bore. So it's a tidal bore on the Petitcodiac River during neap tides. So when tides are the lower types of tides. So there's neap tides and spring tides. Spring tides are 30% higher than the neap tides, or even more. And anyway, I'm just using the drone to follow the tidal bore coming into the Petitcodiac River here. And then let's just have a look at what the area looks like. We don't need to follow that bore. There we go. So this is what the area looks like. And you can see there's mud flats and salt marsh that are incised by these channels. You can see the drainage pattern. You can see to the south, which is the direction we're looking, is towards the Bay of Fundy. You can see how shiny the mud is. And I just wanted to show you the landing here because you can see what we're working in here. And here again, we're doing orthogrammetry. So we can study the relationship between bird tracks and animal traces, which is a little bit esoteric, but it's really good training for the students. And it makes for really interesting research that has applications to understanding the fossil record. And I'm supposed to be landing on that helipad that I have there. And for some reason, I had great difficulty with this landing. You can see the microbially induced sedimentary structures there. And anyway, I crashed the drone, but it was on the soft mud, so it was not such a big deal. No, I didn't mean to do that. And then going back to the Petitcodiac River, when the tide is really low during the spring tide, the floor of the Petitcodiac River channel is mostly exposed. Not much of it is underwater. So you can go and look at all the great sedimentary structures, ripples, dunes. Look, there's a bank on the right-hand photo here. And in that bank, you can actually see this horizontal stratification, which is probably in part related to the intertidal stratification. And if you look around, you'll actually see inclined heterolithic stratification related to the point bars. Now, here in the channel, where we're in the Petitcodiac River channel with the tide out, you can actually see pools of fluid mud. And fluid mud is mud that basically is in concentrations of water that exceed 10 grams per liter of clay and silt. And here you see there's ripples that are draped with fluid mud and have fluid mud troughs, which is where flazzers come from, for example. On that note, you can dig a little trench there and you can see sandstone, mudstone. Well, not stone yet. Sand, mud, sand, mud, sand, mud. Perfect wavy bedding like you would get right out of a second-year sedimentology textbook. Takes a bit of an eye to see it because you got to look at the texture because the colors are both red and oxidized owing to the source of the sediments here. On the right, again, a little Macoma living in sand. And here's one of those point bars I was talking about. It's a pretty large Petitcodiac River point bar. Its overall relief is about 10, 11 meters. And you can see the inclined heterolithic stratification here. Nadine Pearson back in 2006 was working on these point bars after Ian Armitage introduced us to them. And you can see that she established through grain size analyses and whatnot, a general facies model for these bars. And that was from fine silt at the bottom to coarser silt at the top, which was interesting. Why would it coarsen upwards? Well, that's because the prevalence of fluid muds lower down and they just concentrate the finer grained silts for some reason. So the coarser grained silts are trapped up here. Also notice the bioturbation increases upwards until you get to the intertidal flat. And this is one of the few facies models where bioturbation actually increases upwards. You think of deltas, shore faces, they become more energetic upwards, and trace fossils tend to become rarer upwards. But in these tidal bars, the overall energy is focused in the thalweg, and so you have lower sedimentation rates and higher bioturbation intensities as you go up the point bar. We even did seismic on these bars. Normally on a field trip, I would bring out a poster of this so you can see the seismic and you can see the laterally accreting surfaces here. For scale, this is a kilometer of bar. It's down on the Petitcodiac River in an area called near Boudreau Flats here. So we're looking at these sections and look at this reflector here. This is in meters, so depth of channel 7.5 meters. But this light reflector here, that's fluid mud. There's about 40 centimeters of fluid mud just swooshing around the bottom of that channel. And I think that's pretty neat. So this all relates back to teaching moments for understanding what tidal point bars are. An inclined heterolithic stratification. First time I really saw it well depicted in a diagram was a Clifton diagram from one of his field trip guides back in the early 80s, where he showed heterolithic beds associated with laterally accreting point bars associated with the Palix River channel at Willapa Bay, for example. This was more generic than that. And then ultimately, there's also been a lot of work done with dip meters, point bars, and whatnot. This paper is from Uwai and Smith, Smith has sadly passed on. That he did wonderful work on inclined heterolithic stratification. And you can see here that there's not just lateral accretion like Clifton shows, but he showed that the vertical accretion can be prevalent and important as well. And certainly in the finer grained parts of bay and estuaries, we find that the prevalence of vertical accretions are very important. Now, the last video I'm going to show you is the Petitcodiac tidal bore. This was taken, quite a few years ago by JP and I. I think this one was JP and I anyway. And what I'll do is I'll just show you how. So you already saw the Neap spring tidal bore, and it wasn't just stacking. It wasn't that much to sing about, but now look at this spring tide tidal bore. Look how big that wave coming in is. And pardon the shaky photography, but there, now we can see the bore coming in on the Petitcodiac River. Isn't that fantastic? Hey, you could surf that bore, and people do sometimes. I'm not sure you would want to do it right here, but that is really a phenomenal thing. And you can see the water is coming up so quickly now that the camera work's getting shakier because JP and I are realizing we've got to scramble up the bank or we're going to get ourselves good and wet and muddy. And so our last stop is going to be Shepparton River Estuary. This is just going to be a little bit of fun. You know, at the Shepparton River, it's very muddy. It's very accessible. We usually park down here by this dam and causeway, which blocks the tidal channel and just leaves this tidal system here. And then we can hike in across these mud flats here, and we poke around the channels here. Not too far from here, Nadine Pearson did this model of Facey's architecture of intertidal flats that includes horizontal intertidal flat stratification, IHS, and bioturbation distributed between in all of these. This is from Nadine's thesis, and it's a good Facey's model for all this. It certainly shows how dynamic the sediment distributions are and the bedding architectures are on these mega tidal flats. And we would discuss that on the field trip. But first you got to get there. So I'll just show you. One of the problems with Shepparton is it's great fun because it's accessible and muddy, but you can see that getting around in this mud is not necessarily for the faint of heart. That's me. I'm the most experienced on mud, so I'm doing the on my knees, hands and knees, getting the most surface area on the mud bar as possible. But I'm still going slower than the students, which is a little disconcerting to me. There we go. Just having a closer look at the Shepparton River, and you can see there's a channel there, and we can go. This is supratidal flat where it's vegetated in areas, and then you get down to the inner mud flat, the mid mud flat, and then the lower flat. It's all muddy. There's a bit of sand in the channel. Again, Nadine did some work showing the animal distribution associated with these bars, but I really wanted to emphasize her schematic on the right, which was based on a very careful outcrop logging of one of these exposed bars. And you can see that it goes laminated, burrowed, laminated, burrowed, laminated, burrowed, laminated, burrowed, laminated, burrowed. You're looking at seasonal couplets here. The IHS on these bars, the laminated part is in the winter, when it becomes antagonistic to animal colonization, and the bioturbated part is in the summer. So you're looking at seasonal rhythms there. Nadine wasn't the first person to remark on this or publish it in a thesis. Dalrymple wrote a paper on these burrowed laminated alternations and intertidal flat deposits in the Bay of Fundy that were clearly seasonal and winter related as well. So, and I think Dashtgard followed up on that with another paper that we wrote together with Nadine and a couple others that at least touched on that. We always have a little bit of fun at the Shepparton River, and there's nice mud holes at the bottom of some of these channels, and they're soft to jump into. And so I always like to have a little bit of a cannonball competition into the mud. So there's two Scotts here, Scott Melnick, Scott Botterill. That's me. I'm the old guy, but I've got the most air on this jump without a doubt. I'm pretty proud of that. And then if we have enough time and the day's nice enough, we otter slide down these point bars because they're so muddy and slippery that you can slide on your tummy from the top of the bar all the way down. So it's like tobogganing without a sled, and it's awfully fun to do, with kind of the downside that you get pretty muddy at the end of it. And so this is my research group. They're all great people, and you can tell that anyone who's willing to get that dirty must love geology and science. And I've certainly had other field trips that were as fun as this bunch, but certainly not more fun. That's it for this field trip and presentation. I thank you all for attending, and I look forward to, in the fall, sharing another Stelck lecture with you. And at this point, I'd be delighted to take questions. I'll open the chat. Oh, there it is.
Murray, I have a question.
Okay, go ahead.
The motel where you stay at, I hope they have a pressure washer on standby when you guys show up, because it's going to be disaster for the folks there.
Yeah, we have to put some thought into that. We've even stopped at car washes and cleaned ourselves off with pressure washers at the car wash. And sometimes the equipment needs that. At this location here, one of the reasons we go mudsliding at this location is the causeway dams a little lake there. So you can scramble down to the shoreline of that lake and jump in and have a swim and get pretty clean. But yeah, you can definitely... even the vehicles, it's pretty easy to get zinged with a cleaning charge. So you kind of have to build that into your field trip funding model.
Well, thank you very much. That was really informative. Gives you an appreciation for the magnitude and the strength of that tide. It's amazing.
Oh, it's stunning. And if you go to Cape Split, where it's the narrowest part that separates the Minas Basin from the Bay of Fundy proper, the Cape Split's maybe a mile across, and at maximum tidal currents, it just roars. And Ryan Lemiski asks, did I make my students drive to Nova Scotian University vans? Well, I don't know if Ryan, a former MSc student of mine, is hinting at me being cheap or something. But what we did for this one is, for the Ichnology Research Group field trips have been organized by the students for about 10 years now. And they tend to go to oil companies, and they've been sponsored by, for example, BP, Imperial, Shell, the CSPG. And so the students raise the money, and my commitment to the field trip and JP's is that we offer to provide educational experiences for our grad students. But they raise the money and organize the trip, and then I just go out and teach them. So. All right. Well, I'll let those of you who want to go enjoy your lunch do so, and I'll just stay on for anyone who wants to chat briefly after. And hello, Arjun.
Hi, man. How you doing?
Good. Absolutely. Absolutely. Everything's fine. Just need this pandemic to end. Oh, there's Willem. I saw Willem made a comment on the talks. That's good. Oh, I can stop recording now. That's good.
Yeah, I love